Okay, last time we finished off talking about pointers, right? We finished talking about pointers, and now we're going to move on to static arrays. And we'll see that there's actually some similarity between pointers and arrays, but we'll get there. So the point of this lecture is to see how to make static arrays in C++, and see how to use static arrays, and how pointers work with arrays, and how arrays are static arrays, and arrays in general are going to be annoyingly limited compared to what you're used to from 161. And we're going to see how static, I just said that. And we're going to see how to pass them to functions and just use them in general so you're familiar with them. So static arrays, and I'm emphasizing this for a reason, because in the next set of slides we're going to learn about dynamic arrays. But we'll get there in a moment. So static arrays means that the size is known, although that's not necessarily true. The size is fixed, and that it's not going to change. I hard code in my program. I need an array that's this big. It's hard coded. So when the computer starts running the program, it knows to go create this array in RAM over here, and it can't change once it's created. It's stuck. It's fixed. But it needs to know before it starts running how big of that, how much space it needs to set aside. So that's why we have to hard code these things. It's fixed. So we would write it something like this. Int foo, and then open brackets like that, square brackets. And we would put the number inside the square brackets to mean how much space do I want. So based on what you know, you look at this, what do you think the type of this array is? Int. So what do you think is going to be in there? Integers. And how much room is there in there for those integers? How many ints can I put in this array? 5. 1, 2, 3, 4, 5. We start counting at 0. So the length of this array is 5, but what's its last index? 4. What's the index we start with? 0. Good, yeah. So we've got this situation. How many ints can fit in there? Well, we just answered 5. How many ints are in there right now? None. Depends on how we think about that, actually. I mean, realistically, the answer here is none. But what's interesting about C++ is that the computer, when it runs, it's going to say, oh, I need to go create an array over here, and it's going to be size 5. There we go. I've created it. It's ready to go. They didn't assign any values in here yet, but it's ready to go. But the funny thing is, as far as the computer's concerned, there's already zeros and ones in that RAM. There's those high voltages and low voltages and those like transistors, right? There's low voltages, high voltages, zeros and ones that the computer could interpret as an integer. You didn't assign it, but there actually kind of is an integer in there. It's just the computer will decode whatever the zeros and ones in that array before you actually assign any values there. It's going to interpret those zeros and ones as an integer because it's an integer array. So this is just something to keep in mind. In Python, if you created something, it would give you like default values. Oh, you'd have an array full of zeros or something. But in C++, it's going to be an array of whatever the heck is in that RAM that it decided to use for that array. More on this in a moment. So if I do something like this, actually in a moment, here we go. If I run it, I get this. If I hit run, did I put any integers in that array? No. But when I said, okay, create the array, and then here's a for loop. I to 0, I less than 5. Why? Well, because that's how big the array is. I know this. And I++, print out foo at location 1, or 0, then 1, then 2, whatever. That's the loop. That's what the loop's telling me. But every time it goes through, it prints out negative, what is that? 8 million? No, 1, 2, 3, 1, 2, 3, 1. 858,993,460. Negative that. What the heck? I never put that number in there. But the computer actually interpreted that. Now here's the funny thing. This is actually, I'm not 100% sure on this. I think this is a specific Microsoft thing that it uses that value as kind of like a default thing for its like debugging and whatnot. But if you're using a different C++ compiler, you would get just garbage. More on this soon, you will see. So here we go. What do you think is going to happen if I do this? Error. What type of error? Who said error? What type of error? You can't remember? What do you think?
Index out of range.
Index out of range? What are you going to say?
Arrays of size 5.
Well, yeah, that's why we've got the problem, right? There's only 5 spots in that array, and I'm saying go to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9 don't exist, right? Well, if I hit run, this is what I get. I don't get an error. It runs just fine. Here's the thing. That array is in RAM somewhere. Think of the RAM like this. Assuming this marker works. Nope. I've got RAM. We're just gonna visualize it like this. Just goes on like forever, basically. Pretend. And I create an array of size 5, meaning 1, 2, 3, 4, 5. Perfect. This is like my array. The computer went and found this chunk of RAM to make the array. Whatever. When you index the thing at location 0, it gives you this. Index 1, it gives you this. 2, this. 3, 4, 5, 6, 7. It'll do that. You gotta be careful. If you thought that in like Python, when you were getting those like index out of bounds errors, and you're like, oh, these are a pain, you're going to miss them. Because Python was doing you a favor. It was saying, no, you're over-indexing here. C++ is going to be like, all right, whatever you want. There you go. And see how, like, clearly this is just garbage. Like, that's it. Yeah?
The address is like sequential, like one right after the other.
They'll be sequential, but they won't go up by 1. Were you in lab yesterday?
Yeah, so like, but like I need like the next address.
Yeah, they will be sequential. So, like,
Yep.
Yep, so we could just go, there we go. Yeah?
Are there supposed to be 6 negatives on today?
6, what?
6 negatives, 4 positives are the same thing.
Yeah, sure, yeah. Why?
It's like 6 months.
Yeah, but I never assign anything to that variable. It could be garbage, yeah. Now, again, this is C++ and Microsoft, like Visual Studio. So that -8.5, that's actually like in hex, it's like FCCC or something. It's like a special code that Microsoft uses for its like debugger. So we've got the 5 because it's like, well, this isn't really created. And that last thing is probably to check for that type of stuff for the debugging purposes. I'm not an expert on Visual C++. But if you were using like GCC, G++, like another very popular C++ compiler, I'm pretty sure it would just be all garbage. You don't know what you're getting. It's whatever happens to be in there. Yeah. Okay, if I do this, what's the size of this array going to be? You've never seen some code like this before, but I want you to guess. Well, how many things are going to be in this array? And what are the things in this array? 5, 6, 7, 8, 9. Exactly. So if I print this out, I'm going to get 5, 6, 7, 8, 9. As a note, you don't actually, if you do this way and you just like hard code what's in it, you don't actually need to put the number in there. It'll figure it out for you. FYI. Yeah. How about this? How many spots will there be in this array? I mean, now I clearly just showed you, like, really it can be as big as you want, no matter what size you make it. But 5. But how many things will be in it? Exactly. So index 0 will be 5, 1, 6, 2, 7, and then whatever. So far, so good? Yeah. Okay, there we go. I don't know why there's one random question mark there, but whatever. There we go. different types of arrays. So of course I can have integer arrays, that's what we've been playing around with. I can have character arrays, I can have Boolean arrays, this is going to be fine. You can do whatever you want. But you might start to notice, like unlike the lists, you're going to have a hard time mixing types. You can't have an integer array with strings in it, right? Although, you can do something like this. But who remembers from what I was saying last time why this will work? It's going to just interpret all these things that you put in as integers. They're all primitive types. The series of zeros and ones for the character A will be interpreted as if it was a series of zeros and ones for the integer, which happens to be 97. And true, it's going to be interpreted as whatever the integer version of true is going to be. But, yeah, so yeah, there you go. Here's an example of me trying it out for fun. Look at that. Look, first I treated it as if it was an integer array, and then I printed out the results. I got 40, 40, so it just truncated the decimal off the float, or double. 97, because that's ASCII for lowercase a, and then 1 for true. True, I guess, is just 1. Makes sense. But now I said, no, interpret these things as characters and print them out. What do we get? Left parentheses, A, and then it just, the computer was just, that's the computer going like, well, I can't, this isn't a thing. So this is going to be the problem. As soon as you start trying to mix things that aren't primitive types, by the way, if you ever want to start doing the mixing of things that are primitive types, you gotta be really careful. Chances are you probably don't want to do that. You can do it, go ahead. If you want to do it, absolutely do it. But in general, that would be a weird thing. You don't do that. This absolutely won't work. It won't even compile. You're trying to mix types now that are more than primitive types. It's not gonna, it won't work. Because it can't interpret 40 as a string. It doesn't know how to interpret those zeros and ones that mean the integer 40 as a string. It just can't. It's not going to do that for you. If I do this, what's going to be printed out, do you think? It's kind of a trick question. Take a second look at it. What would make sense? But I'll give you a bit of a hint. C++ is really good at interpreting random zeros and ones as something as a primitive type. It's happy to do that. But of course, we're not pretending these are primitive types. They're strings. Oh no, don't cheat. Let's actually just run it and see what happens. It's doing its thing. There we go. F5. Don't know why it's being so painfully slow. Something's happening. Here we go. So first it said hello, then world, but then the debugger came up and said, we've got this access violation thing. But that's because let's see what happens when I run it again. So I just ran it in debug mode. I'm going to run it in not debug mode. Debug mode's like a special version of running that means like run, but pay attention to what's happening for me to see if there's like an issue. Not debug mode, it's just gonna do what you told it to. The debug mode is being nice to you. There, I ran it in not debug mode, and it just printed out those two things, and it carried on, I guess. But we do know that we were trying to access stuff that really wasn't there. So we just have to be very careful. That's all I'm saying. Questions about any of this stuff? You're just going to get used to it. Practice, practice, practice. You won't even think about it soon. You're just going to be using it. So whether or not it crashed kind of depends on how you're running it. What's going to get printed out if I do this? 7, great. What happens if I do this? Take your time, look at this. I'm just trying to throw you off, see if you can interpret it. Raise your hand if you know. Raise your hand if you want one more second to think about it. Okay. All right, so who wants, someone yell out what's going to be printed out.
5, 6, 7, 7, 8, 8, 9.
Perfect. 5, 6, 77, 88, 99. Why? Well, so we have 5, 6, 7, 8, 9. Foo at location 2, which is 0, 1, 2. Okay, that's the 7. Turn that to 77. Foo at n index, well, n index is 3, so that's the 8. Turn the 8 into 88, I guess. And then last, being weird, but foo at location, okay, what's foo at 1? 0, 1, that's 6. What's 6 minus 2? 4. So foo at location 4 becomes 99. And what's 4? 0, 1, 2, 3, 4, that's the 9. 99. There's not really a trick here. I'm just showing you can access, you can assign, all that type of stuff that you're used to with these types of things. What do you think about this? Does this look good to you? Whether or not it runs, I suppose, is irrelevant. The question right now is, does this look safe to you? Yeah, you like it, right? The correct answer is no, this is not good. This is dangerous. It'll work, but you shouldn't do this. This is very dangerous. It's going to kind of do the same thing. It's going to be like, oh yeah, you want to go here? You want to go here and assign it? Great, cool, whatever. Yeah?
Does adding the foo 5, foo 6, foo 7, does that add it to the actual array?
No, this is still, this part here is still like the array. This stuff isn't a part of it. And the reason what you're doing is very dangerous is, for all you know, the information in this cell might be super important nuclear fuel rod value. And then suddenly what did I do? I just overwrote it. Even though I never used the variable called super duper never touch, never change constant, I just changed it though. I messed up RAM. Yeah?
When you override it like that, does it get reallocated?
Nope, it's just going to be like, all right, you're gone. Yeah. Did you tell it? I mean, C++ isn't going to do much that you don't tell it to do.
I was hoping Microsoft.
No, Microsoft's, nope, sorry. Yeah.
Could you just throw additional commas at the end to just create blank spaces?
Yeah, you could, yeah. Or what you do is you just, there's a really, okay, this is an issue that you will run into, don't get me wrong, these things will probably come up, you'll make these mistakes, everybody does. But don't be too worried about this thing jumping up at you all the time, because what you're typically going to do is, you're hard coding this, like these are static arrays that you know the length of. So maybe you have like a constant value that's like, this is my array size, it's fixed, whatever. So whenever you want to loop through it, like you just use that variable, the constant, for example. So like you're probably going to be fine. I'm just showing you that you can get really hacky with this type of stuff. You had a question?
Yeah, I was gonna say, if you put it in like a spot outside of the array, you don't have any like variable name pointing to it, then it's just there, right?
It's just there. I can still get to it by accessing foo at location 7. But there is no variable, like
Yeah.
C++ did not allocate that RAM for you. So C++ might freak out. Here, let's see what happens if we run it without the debugger and with the debugger. Let's see what happens. So that's running it without the debugger. But you'll see that I did get a warning that says stack around the variable foo is corrupted. That's a phase. Stack in this situation is like the memory. It means more than that, don't get me wrong, but for us right now it's saying like, something funny happened. It ran, it's cool with it, but this is Visual Studio being like, something funny happened. That's running without the debugger. Like ignore, okay, great, happy. Yeah. Now I'll run it with the debugger. It's probably going to give me like a pop-up. Yeah, there we go. It's giving me slightly more information, saying, yeah, something funny happened in main, I guess. Any other questions about that stuff? It's weird, right? Coding like it's 1980. So you can have multi-dimensional arrays like you did, like multi-dimensional lists. You can declare it like hard coding them, something like that, or you can create like arrays and arrays, you know. But this will work out. If you hit run, you'll get something like this. That's all. This shouldn't scare you. It's basically the same stuff we were doing in Python, but now it's with arrays. How many dimensions does this array have? It should be really easy. Yeah. So how many dimensions does this array have? 1. How many does this one have? How many does this one have? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a big array, but it's all good. So you can also pass arrays to functions, just like, you know, all the other variables and like you were doing before. So have a look at this code. Give yourself a second, look at the code, make sure you understand what it's doing because it's going to be critical for the next couple of slides to see how things might change. So come up with like what's actually happening here. It's not a trick question or anything, I just want to make sure you got it. So note that like print array, it's going to be a safe function assuming that we get our array and a length is the correct length of that array. So we don't have to worry about going out of bounds if the person's using the function correctly. But all it does is we create an array down here in main, we call print array on an array, and just the function just prints out the contents. That's it. Nothing crazy. So arrays and pointers are going to seem very similar. In fact, Who here was thinking that when I started drawing RAM like that and whatnot, that you kind of had pointers in your mind? It's fine if you didn't, but if you did, that's good. In fact, this might be more obvious for those of you that were in lab yesterday. If I have a pointer, right? And I don't add anything to it. Like if I add 0 to it, the pointer's going to be left alone, right? So imagine I add a pointer to this piece of RAM and then I add 0 to it. Where should I be pointing at the end of that question? Same spot. Interesting. What happens if I give you this pointer and I added 1 to it? Where should my finger be? 4 spaces over.
I thought it was 4 bytes.
Yeah, but this is one slot for an integer. So assume that this is the size of an integer. Like this is the room for it. Okay. So where should let me ask that again with that information out there now. Where should my finger be pointed? Here. What happens if I give you that pointer and add 2 to it? Where do you think I should go? Interesting. If I were to run this code, who wants to guess? There's a good chance you haven't seen something like this before. But what am I asking, and what do you think is going to be printed out? Without ever having seen this before, I want to know if someone can kind of piece it together. If you're confident, raise your hand and we'll see. I dropped a bunch of hints before. Say that again, but louder for everybody. That wasn't really louder, but you were right. It's going to print out the memory address of where the array starts. So if the array starts at memory location 4, like let me pick another number. If the array starts at memory location 702, which memory address do you think the number 4 is in? 702. Huh. Interesting. So to actually print out the memory address, you don't need to do the ampersand here because the array kind of is like the pointer. It's the memory address of where the array actually starts. This should sound familiar to those of you that came from Python. We talked about this and how our lists are really things that get us to the front of the list, where they start. What do you think this will print out? Exactly, the same thing. An array and the address of an array at location 0, they'll be the same. Yeah?
So that first one at the top level only print the address of the first.
Only the beginning, that's it. All it knows is where the array starts, that's all.
So to get any of the others, you have to do the method at the bottom if there are.
Exactly. In fact, that index, all it's doing is like the pointer arithmetic kind of. So like this location plus 0 is still here. This location plus 1 is here. That array indexing is kind of doing that fancy pointer stuff for us. So this right here, this is absolutely valid code. This code's fine. Because my array, which is an integer array, and integer pointer, they're both addresses of an integer. They're the same. Do you think this is valid code? Because so we know like if I had an array at location I, that's clearly valid code, right? Because an array is the array. But what's weird about what I'm doing here is that I'm trying to access a pointer as if, like I'm giving an index to a pointer. So that seems weird, right? Let's see what happens. Try not to read what I have there to spoil the fun. Being really slow because I messed it up earlier and then I couldn't restart my computer to fix it because My computer wants to update. And it was like 5 minutes before class, so it works just fine. You can do this. You can like interchange the pointers and the arrays. It's weird, right? But okay. Who here likes this? Who here doesn't like this? Who here doesn't really care? Yeah, okay. Well, what would you tell me what would that mean?
I thought that would give you what it just gave you.
But my pointer at this location, whatever we put in those blocks, it's doing like the dereferencing for you. So you don't need the star. So I can't dereference something that's just like an integer, for example. That would be like saying like dereference the number 5. It's like, well, that doesn't make sense. That's not a memory address. I can't tell it to go where it is. You're right. That if I had, you know what? I think maybe on the next slide it's going to answer your question pretty well. Or address your concerns pretty well. There we go. Have a look at this code. I kind of already did this one together. Let's think about what this means. My pointer is a pointer that gets me to the beginning of the array. Why? Well, because I assigned it to array at the start. So if I say memory address, my pointer, let's say this array starts at memory location 1000. Okay? We're at memory location 1000, so that means my pointer is 1000. And then the very first time through the loop, what's I going to be? 0. What's 1000 plus 0? And then I say dereference memory location 1000. Which box do I get? This one. Next time through the loop, what's I going to be? 1. What's 1000? Now this is a bit of a test for those of you who were in lab yesterday, and a giant spoiler for those of you in lab today. What's 1000 plus 1 integer? 1004. For those of you who are in lab today, don't worry, you'll see. So 1004, which will get me here. And then I dereference it, so I get what's inside of it. So you will see, like you can probably now see that the indexing with the square brackets and this kind of doing the exact same thing. And I think this probably hits your concerns, eh? Or maybe not quite? You'll ask after? All right, we'll figure it out. Okay, take my pointer, which is a memory address, pointer, add whatever I is to it, and dereference that address. You think this will work, though? Sorry, can you just say it louder? I couldn't quite hear. Yeah. All it's going to be is, if I created this memory address, or this array, it's like 5, and it just happens to be at memory location 1000, in this particular example. Next time I hit run, it could be at location 7014, or whatever. But right now, pardon?
Whatever the address
of where the start of the array is. And so an array is really just a pointer to that. So then when I say int star my pointer equals an array, the pointer, or my pointer, will also be 1000 in this situation. So they're going to point to the exact same memory location. So raise your hand if you think this will work. Raise your hand if you think it won't work. Raise your hand if, well, maybe it'll work only because C++ apparently will let you do whatever you want. Yeah. Let's see. Like previous slide, we're treating the variable myArray as just a pointer. If you print it out, it'll give you the memory address. And what's the memory address plus a value? It just moves it down. Pointer arithmetic is cool. My recommendation, though, is if you created an array, use the indexing. Don't do this. Like, this is weird. This and this, strange. Absolutely valid, legal C++ code. It won't even get mad at you. But if you've created an array, follow the conventions and do it the other way. I didn't even realize this. Someone last year got to like the end of the semester, and they kept doing it this way. And then I was like, why? They're like, well, what other way is there? I'm like, the easy way, this way. And they're like, oh, well, it'll work, it'll get you there. It's going to be a little bit more complicated, but it'll get you there. Yeah, great. Okay. Have a look at this code. What? So this code is going to be very similar to that code I told you to check out a couple of minutes ago. What's this code doing? Based on everything we saw, does this make sense? Are you happy with this? Unhappy? What do you think? Looks pretty good? Looks pretty good, right? I can pass the array, an int star, that's a pointer, but we know that an array is also like a pointer to the beginning of it, and we know we can index the pointer like an array. Yeah, this checks out. It's happy. So remember this situation. Remember how I was saying before it matters, am I passing the value or am I passing a pointer to that value? Yeah, like the referencing, although we got to be careful by using the word referencing because references actually mean something slightly different. But we'll worry about that later. So remember this case, how we have to be careful. In this situation, what will be printed out down here, we will see 1, 2, 3. Why? Well, because C gets modified because Z isn't an integer. It's a pointer to the integer, whatever's in C. And then when I change Z and I dereference it, then I overwrite whatever was in C. So this is how it worked. Look at this example. Take a moment, think, what would be printed out here? Raise your hand if you're like, yeah, I know. What do you say?
99.
Why? Perfect answer. Because it's a pointer. An array will get me to the exact same one single array in RAM called an array. Or like that for. It gets me to that memory location. What about this one? It's not a pointer anymore. What we're doing in that parameter there at the top, int an array, we're saying, oh, create a new integer array thing. And it's actually, it'll copy over the contents for us. Let's verify that, just to make sure I'm not crazy. Oh my gosh. What the heck's going on here? Does that make sense? I see half the people in the room going, no. And the other half going, yeah. What? I think you were shaking your head, yeah. Can you try to rationalize it? Yeah.
I mean, well, you're saying that like an array basically is a pointer regardless, so it doesn't matter if you call it a pointer or not.
I guess so. But what?
I was gonna. Does this create like a new array, or is it still?
It's all it's going to do is create a pointer to a memory address for an integer.
Oh, so it's just.
It's still just the pointer. It's still all, like, here's the thing. I was trying to trick you because as soon as all you had to do was follow all the rules from before. This is where people get upset though. Because, well, how come we were able to do the references before and then copy the values over before? Shouldn't we have that freedom again? We gotta be careful. Yeah.
So does that update the array to be 993210?
Yeah. It's 993210. Yeah.
Does that make like the start basically useless in the last?
The star, it's not that it's useless, it's just that the int star and int blah 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 square brackets for the array, it's the same thing. Yeah.
When you define it as int and array, is it still a integer pointer, or is it a different number?
I don't know really on the back end. For all intents and purposes, it's still just a pointer to an integer, the beginning of the array. There might be some interesting slight difference in the back end that I'm just not aware of, but for us, we can think of it as it's just the integer pointer.
So int on array square brackets acts the same as like an integer pointer would?
Exactly.
Okay.
Yeah, and an integer pointer acts the same way as an array of integers.
Could you have like indexed that so it would have changed something else rather than the first one?
Oh yeah, absolutely. We could have done an array at location, I mean, really, we could have done an array at location 99, and we would have screwed around with RAM quite a bit, but we could have. We've created all these things, they're fixed arrays, but that array is always going to be size 5. Always. No matter what we do, it's going to be size 5. Who here thinks that's good? A couple people. But like, what if, like, you have to understand, when you create an array like this, you can't say, oh, user, give me a number. Now I'm going to go create a static array of size, whatever number you gave me, and then it's never going to change. That's not what it's going to do. It won't let you do that. That would be more of like a dynamic one, where it can be different every time you hit run. This type of array, you need to know before you even hit compile how big that array is going to be, so the computer can go find out how much RAM it wants to put. It needs to set aside. So you need to know how big your array is going to be before you even hit compile. Who here finds that slightly restrictive? Yeah, you had a question?
Yeah, like in lab when we're working on the cache problems, if you don't like you do like a character in, for example, and like work around it and then define an array to have like that size you store the character in value as a variable. Would that just is that not a static array then?
Well, you'll see.
Okay.
So yeah, you might be compelled to do something like this. Does this look like reasonable code to you? It should. How big do I want the array to be? Get it, then make the array of that size. I got bad news, you can't do that. Not this way. But we can do it, we'll see next time. So if you don't know how big your array needs to be, that might not be that big of a deal though, because often what we'll do, here's a big tip, is often what we'll do is, let's say I know I'm writing this program, and I'm going to ask the user for input, and I need to have an array, but I don't know how many things they're going to give me. But I do know that they're not going to give me more than 100 things. So what I will do is I'll just make an array of size 100, and then use how much I need. Does that seem reasonable? Right? So I'll know that the array is size 100, but I'll ask him for something, and then I'll put it in location 0. And then I'll remember the next available spot is actually location 1. right? So then, give me another thing, okay, then I put it in location 1, then I always remember where the next available spot is. So the array, there's gonna be a lot of empty space, but I'm safe. So all is not lost. A static array could be just fine. Yeah. Okay, some people were asking about this. There is something called the standard array. You could use this, and really outside of like 161, you would be encouraged to use this or other data structures. But the way we've got it, we're not going to use the standard arrays in this class because part of the reason we're doing C++ and playing around with the pointers and having static dynamic arrays is that you get a chance to get experience with all these different things. So this does exist, and what's cool about this is if you create it, so standard array, what do you think's in those triangle brackets? The type and how big it is. There's this thing, you can, like, it's cool. You can ask how big its size is, for example. It's just handy stuff. But we're not going to use this. But by the way, it's a thing. Yes?
Is there a major difference between a standard library array and like a vector?
Yeah, there is a difference. Vectors are just going to be much more general purpose goodness. They're going to be closer to what you're used to with a list, for example. Yeah. All right, cool. We'll see you later.